should we talk about? What was the last one? Did you say 4?
Yeah.
So they give us A, B, and A plus C. Or A plus B, yeah, thank you. And we're supposed to put this on a triangle where the bottom two get added to make the top, and the top subtracts either of the bottom to get the other bottom. So this is a term. That goes in one of the corners. This goes in a corner, that goes in a corner. Yes? Yes. What goes up top?
A plus B.
A plus B. So these put together. And then A goes on the bottom along with B. So A plus B equals A plus B. It's a little misleading with the variables, but that's it. Anything else? Did I give you 14?
Yeah.
Yes.
Yes. What does it equal? Oh, I don't know. What does it equal?
9/10.
Is it 9/10? There's a 2, a 3, a 4, and a 6 for the denominators.
Well, y'all can make those all 12.
Yeah.
You can make them all into 12ths.
Yeah. So that's 6 12ths, 4 12ths, 3 12ths.
6 12ths, 4 12ths, 3 12ths, and 2 12ths.
Well, you're supposed to simplify and not solve it, I thought.
Well, if you're simplifying, you're writing with fewer symbols.
Yeah.
So if you're allowed to add, you can add them together. That would be simplifying.
Oh, no, I mean, like, I'm talking about you're not supposed to solve the problem completely, I thought.
That's Isla, that's mine. That's a distraction. That's beyond. That's mine. Bring up your leisure. So if you have a negative 6 12ths, and a third is 4 12ths, what's the next term? 3 12ths, because it's a fourth, but that's a negative, isn't it? And then what's the last one? 2 12ths, positive or negative? So can you put those two together first, since they're both negative?
Yes.
So negative 6 and negative 3 is negative 9. And then the 4 and the 2 is 6. And you can use the same denominator.
3,
So it'd be negative 3. Can you simplify it?
Yeah. 1 half or negative 1 half.
Negative 4.
Wait, no, but I thought only there's only one negative number in there, though, I thought.
Well, the first one's negative, it's a negative 1/2.
Yeah.
And then it's a, if you're subtracting a fourth, that's the same as adding a negative fourth. So the way this thing started was minus 1/2 plus 1/3 minus a fourth plus a sixth. That's how it started. And subtracting 1/4 is the same as adding a negative 3 12ths.
After they just didn't get behind that, so you say that's my bad.
There's only one negative.
Yeah.
Yes.
Number 14?
Yeah.
Yeah. It's negative 1/2 plus 1/3 minus 1/4 plus 1/6. Yes.
Yeah.
Yes. But I rewrote subtracting a fourth as adding a negative.
Oh.
Yeah, see, if we just change this to adding a negative 1/4, that's the same.
They still get the same answer?
Sure. Six minus 8.
Negative 2.
So if we did plus 6, and then we went back 8, that's a negative 8. If we did this using direction arrows, we did that using a slide model. That's like taking this negative 8 and that positive 6 number and just putting them together. So that's 6 plus negative 8. It's the same. So x minus y is equal to x plus a negative y. We gotta bring the cards down from the other room, because that's up there. It's yellow. Yes.
So why do we have to do the complicated way?
You don't have to do the
Why can't
complicated
we
way.
just do x minus y?
Why?
Yeah, instead of having to have the negative y and the.
You don't have to. It's just another tool, it's another way of looking at it. If you look at a math problem and you can do it this way, you see it, just 6 minus 8, you can see that that's equal to negative 2, great. The problem here, if you left this as subtraction, here's what we'd have to do. We can't take the negative 6 and the negative 3 and put it together. You cannot change the order of subtraction. There's no way to have 8 minus 6 be the same as this, is there? It doesn't work. However, on that side, negative 8 plus 6 is the same. So, in a problem like this, if I change that to the addition of a negative, then I could look at those two numbers, put my negatives together, look at the positives and put those together, rather than ones. Otherwise you have to do, well, let's see, negative 6 plus 4 is negative 2, minus 3 is negative 5, plus 2 is, it gets, sometimes it gets complicated. It's not real bad, because those are numbers. But if they are variables, which is where I'm going with you guys, to teach you how to work with variables, then this becomes a very valuable tool.
But why can't we just add those two like on the left and then add those two on the right and then we minus those two numbers?
Add these two,
Yes, and then you add the other two.
that's
and then
5.
You add them together, or minus them.
So you have negative 2 minus 5.
Yeah.
Well, that's negative 7. That's not what that equals.
How is it not equal to that?
Well, because what you did is you didn't follow order of operations. You did these two, and you did those two, and then you subtracted.
Yeah.
That's not accurate. Here, just do the numerators. Go back to order of operations. What has to be done first? 6 plus 4. Now what has to be done? Subtracting 3, not adding 3 and 2.
No, I'm not adding the negative 2 to the 3 plus 2 or minusing it.
Right.
Yeah.
Yeah, so you're taking 5, and you're subtracting 5, that's what you think?
Yeah.
Can't.
Why?
Doesn't give you the right answer.
Why?
Because the order of operations, the rules that we live by in math say that you have to work from the left to the right.
If it was all addition, could you do that though?
Sure, because the commutative property allows you to change the order of anything. But there is no commutative property for subtraction, so we can't change the order of anything that involves subtraction. You have to work left to right.
But what if, let's say it's multiplying, like you do, let's say that 3 plus 2 is actually 3 times 2. And then
Now you're
10
talking about
times-
different problems, and we
But
have
can
other
I do
things to
that,
do
though?
today. Stop by after school, I'll talk with you further, okay? I'm just not gonna keep changing the problem, spend the entire hour up there. You are taking a quiz before you leave. And you have another assignment, so. Go back to the order of operations. Okay, you have more questions about your assignment? Okay, next lesson then, 5. So last year we did some of this work earlier in the year. And this year the way we're gonna go through this lesson pretty quickly, and the next one will take it to another level. So this lesson can be somewhat reviewed from last year. And the way it's taught, the way it's explained is a little bit different than what we did last year. We used a triangle like this. And we took those 3 variables and you put those into that triangle. So this would be subtraction on the way down, addition on the way up. What goes across the bottom in these 2 places? Whoops.
The
X plus A is equal to B.
B goes to the,
B goes on the top and X and A go on the bottom. So, what are the related facts? We've got the first one, X plus A is equal to B. What's another one? Well,
B minus X equals
B minus X equals A. What's another one?
B minus A.
B minus A equals X. So if X is the value that you don't know, that's the related problem that you can use to find out what X is. So let's put a couple of numbers in. Just keep it real simple. X plus 7 is equal to 10. So what goes up on the top? 10. And on the bottom you've got X and 7. So what's the one related fact? So these are related facts here. What would be the one related fact with this equation that would be able to tell you what X is equal to, Lucia? So it'd be 10 minus 7 is equal to X. Can I write it like that? Is that okay?
Yeah.
Okay. So if you don't use a triangle, how do you know that X is equal to 10 minus 7, which is 3? How do you prove that to somebody? How would you argue to them and say, this is what it's equal to and this is why? Forward? Because 10 minus 7 equals 3?
Yeah.
So if I subtracted 7 from this, that would give you 3, yes? Okay, but then if we subtract 7 from this side, what has to happen on the other side? You have to treat them equally. So both of them have to have 7 subtracted, or you could say that you're gonna add a -7. It could be done either way. Whether you wanna look at it as adding 7 negatives or subtracting 7. It's gonna come out the same. Or you can look over here at this triangle and look for the related facts. And 10 minus 7 is gonna be equal to x. So do you remember doing these last year? Yeah, so if you do add 7, subtract 7, that becomes x, this is equal to 3. And then you would go back and check by putting 3 in here. You can manually check, or if you have to do it on paper, 3 plus 7 is equal to 10. So, I'm trying to think. I don't think that I assigned questions that ask for properties. So I'd rather have you have more work time for your quiz and more for homework. I'll say this, in questions 5 through 10, when you're working with these, where they're giving you an equation like this, I'd like to see your work using inverse operations. Do one more problem. So if you had something like that. What can be done to both sides of the equal sign that gets C along? Would you want to add 17 or would you want to
12.
work with the 12? So what would you do? Would you subtract it? Okay. What would you add instead of subtracting? Or what could you add instead of subtracting? A -12, yeah. So if over here you say that you have subtracting 12, this 0 cancels. That makes just C. But if you don't like looking at that in terms of doing the subtraction in your head, you could just say that this is adding a negative. So now you have a -17 added to a -12.
Wait, no.
So you're going negative twice. So -12, -17, -29. Or you can just think of it like this, if that's okay. If this works for you, you know you have 17 negatives, you need to continue making the number more negative by 12 more. However you want to picture this is up to you. Or if you need to envision this as counting, like there's 17 negatives, and now you're going to add 12 more negatives. Everything's negative, right? So there's a total of 29 negatives. So I'll let you work with that after you're done with your quiz. While you're taking your quiz, I'll write your homework problems up on the board over here. That's from yesterday, don't confuse that. Oh, I was thinking that, yeah, somebody over here asked me, can we use a calculator on this? And I'm gonna say no. Yeah, I'll write it down while you're taking the quiz. But no, you don't use a calculator on this quiz. Yeah.
So we don't
You
have
can use your notes, you can use your homework.
Do we have homework?
Oh yeah, you have homework. Are you ready for this? Did you get through the fourth lesson?
bucket.
Yeah, this is gonna be the key, this is gonna be Stacy. Y, right?
Haines.
Oh, okay.
That was the last lesson.